Okay, next thing, when you take the AY coefficient and dou by dou x of xy will be y and dou by dou z of yz will also be y plus az coefficient into dou by dou x of xz will be z minus dou by dou y of yz will be also z. You can see here everything gets cancelled. So the curl of the vector is also a null vector. So since if the curl becomes 0, the vector is said to be irrotational. Or there is another name for that in the previous class I told you. The vector is also said to be conservative. So both divergence and curl are 0 for this vector. So the vector is said to be both solenoidal and irrotational. So can I move on to the next question? Yeah. So if you have any questions, because actually I was going through your chat, if anybody not able to understand, try to reply it in the chat message. So moving on to the next question. So find the Laplacian for the following. So the first one is v is equal to 10xy, v is equal to rho cos phi, and v is equal to 10 by r. So take one by one. So first of all, what is the Laplacian? So in the previous lecture, we have seen the Laplacian of a scalar and the Laplacian of a vector. So whatever all the a, b, c values I have given, all are represents a scalar quantity. So when you remember the Laplacian of any scalar quantity, so that is del square v is equal to the divergence of the gradient. Right? First you find the gradient of each and everything, then you try to apply the divergence. So I will explain it for one case. The second and third case you try to take time and do it. So the first case, the given scalar is 10xy. So what is the gradient of this? When you are finding the gradient, differentiate with respect to x. So that will be 10 into y into ax cap plus differentiate with respect to y. So 10x ay cap, and there is no z term, the differentiation will be straight away 0. So what is the divergence of the gradient right now? You need not to look into the equations again. Since it is in a rectangular system, differentiate ax coefficient with respect to x, differentiate ay coefficient with respect to y. So if you differentiate the ax coefficient with respect to x, since there is no x term here, so the differentiation is straight away 0 plus, and differentiate ay coefficient with respect to y. So here also there is no y, so the answer is straight away 0. So I can say del square v is equal to 0 for the first question, v is equal to 10xy. So can you please say what is that function is said to be? When the Laplacian becomes 0, what is that function is said to be?
Harmonic.
Very good. The function is said to be the harmonic function. Now you please take time and do it for the second question and the third question. The second question is an example for the cylindrical, and the third question is for an example of spherical. So do it for rho cos phi. So you can take the other second scalar function as rho cos phi. So first of all, when you are doing anything, if it is other than rectangular, try to write down the generalized equation. So when you are finding the gradient in cylindrical system, first of all, you need to differentiate that with respect to rho into aero cap. Plus, when you are writing the second term, so there will be a scaling factor of 1 by rho, dou v by dou phi, a phi cap, plus, and since when you are differentiating with respect to z, there is no scaling factor, straight away differentiate with respect to z. So what is the value of gradient you will get? Dou v by dou rho. So when you are taking dou v by dou rho, that will be cos phi into aero cap plus 1 by rho into dou v by dou phi. So when you are taking differentiation with respect to phi, rho is a constant and differentiation of cos phi will be minus sin phi into a phi cap plus dou v by dou z. Since there is no z term in v, the differentiation is straight away 0. So the gradient what you are getting is cos phi into a rho cap. Rho one time gets cancelled plus minus sin phi into a phi cap. So this is the gradient, whatever you have found. So this is in terms of you are getting d rho a rho cap plus d phi a phi cap. Of course, there is no dz, but still I was writing dz az cap. So when you are finding the divergence for the gradient, whatever you have obtained in the previous statement, if you try to have gradient divergent for this, you take this as a something like a vector, where d rho will be cos phi and d phi will be minus sin phi. So write down the generalized equation for divergence in case of a cylindrical. So I can consider a vector something like this, whatever the answer you got in the previous slide, cos phi a rho cap plus minus sin phi a phi cap. So this is a vector you got. So for that you need to find out the divergence, right? So if you are recollecting the divergent equation again, there will be 1 by rho dou by dou rho of rho d rho plus 1 by rho dou by dou phi of d phi plus dou by dou z of dz. Please cross check with the previous class. So I have, this is the divergent equation in case of cylindrical. So try to substitute values, you can straight away do that. So del dot d is equal to 1 by rho dou by dou rho of, so rho into d rho will be multiply rho for the a rho component, so that will be rho into cos phi plus 1 by rho into dou by dou phi of d phi will be straight away minus sin phi, and the third term you can take it as 0 because there is no dz. So what is the value you are getting, everyone? So del dot d is equal to 1 by rho, cos phi is a constant, take it out, and differentiation of rho will be straight away 1 plus 1 by rho, and there will be minus 1, and differentiation of sin phi will be cos phi. So you are getting the first and second terms. First and second term equal and opposite inside sign, so the answer will be 0. So here also you are getting del square v is equal to 0 for the second equation. So you have any questions, you can message me in the chat box. Anybody is not able to follow? So shall I go to the third one then? Third scalar function. Yeah, then one thing what you do the Laplacian for the third scalar quantity, that is 10 by r, and try to answer me that one. You put your answers in the chat. So this I was giving it as an assignment to you. So you can do it and tell me the answer. Then we'll go to the next question. So do it for the scalar function v is equal to 10 by r. Are you able to do, or anybody wants me to explain this? Okay, let me explain. Please cross check your answers if it is there. So when you are finding the gradient in a spherical system, we already written what is a spherical. Dou v by dou r a r cap plus 1 by r dou v by dou theta and dou v by dou phi. So that and all doesn't matter because it doesn't have any theta and phi. So you should write only the first equation. Dou v by dou r into a r cap plus some theta variation and phi variation. So that will be 0 in this case. So what is the value of the gradient you got? Minus 10 by r square into a r cap. So this is your vector and try to find the gradient, divergence of this gradient. So when you look at the divergence of this gradient, in case of spherical, the divergent equation is given by 1 by r square dou by dou r of r square into dr, plus forget about the second and third term because there is no theta terms and phi term. You need not to worry. So 1 by r square into dou by dou r into r square, and dr will be here ar coefficient, that will be minus 10 by r square. So you can see here r square get cancelled and 1 by r square into differentiation of minus 10, since it's a constant, differentiation will be 0. So straight away the answer will be 0 here. So whatever the options I given, right? Now we will go back to the presentation. So whatever all the scalar functions I have given it here, you are getting the Laplacian for that operation will be straight away 0. So there are sometimes, if you see the previous year gate question, they will ask differently. The same question they will ask differently. Which of the following equation will satisfy the Laplacian equation? If any scalar function, if it has to satisfy the Laplacian equation, means del square v has to be equal to 0. That means the scalar function, if it is harmonic, means indirectly you can say that the scalar function is also satisfy the Laplacian equation. So when anybody says if the scalar is satisfying the Laplacian equation or not, then you directly check del square v is equal to 0. If del square v is equal to 0, it satisfies the Laplacian equation, and at the same time the scalar is said to be the harmonic function. So shall I move on to the next question?
Yes, sir.
Yeah. See, this is the previous year gate question. So we can read the question first. The direction of the vector A is radially outwards from the origin with the magnitude is equal to k into r power n. So where he given r square is equal to x square plus y square plus z square and k is a constant. Then find the value of n for which the divergence of A is 0. See here, there is a vector A. The vector A is radially away from the origin. So this is your origin and the vector A is radially away from the origin. So which direction represents radially away from the origin?
R, sir.
R. So which means that the vector A bar lies in the direction of R, correct? So if you want to write the vector, first thing, if you want to represent the vector A, you know that any vector can be represented with a magnitude as well as direction. So since the direction of A bar is radially away from the origin, so the direction of A, you can simply say it's a AR cap. So it will be radially away from the origin. So since the magnitude of A is he already given k into r power n, right? So that will become k into r power n. The direction will be AR cap. And you can see here r square is equal to x square plus y square plus z square. This already we know in spherical system. You need not to worry about it. Then you need to find the value of n for which divergence is equal to 0. So you know that the vector is k r power n into AR cap. So it belongs to which type of coordinate system?
Spherical.
Yeah, correct. So you try to find the divergent equation in case of spherical. So since this is a spherical, you write down the equation for divergent in case of spherical. Just now we have seen in case of spherical, the divergence will be straight away 1 by r square dou by dou r of r square into dr. So the coefficient of AR will be straight away here K into R power N. And forget about theta part and phi part because it doesn't have any theta and phi terms. So he has given the divergence is straight away 0. So what you will get? 1 by R square. K I can take as a constant and dou by dou R of R power N plus 2 must be equal to 0. So what is the value you are getting? 1 by R square into K and differentiation of R power N plus 2. That will be N plus 2 into R power N 2 minus 1. This has to be equal to 0. So forget about this. This and all will not become 0, right? So if the divergence has to become 0 means your N plus 2 has to become 0 and the value of N will be straight away minus 2. So you got the question now? So any questions you have? So should I move on to the next one?
Why
Yeah.
haven't you considered that minus the denominator R?
Denominator R?
Like
There is no minus
so
here. See. So what I was doing 1 by R square into K. If there is a differentiation of R power N, the differentiation of R power N will be straight away what?
yes, sir.
N into R
Yes,
power N minus 1. That part you understood? Huh?
yes, sir.
Yeah. So
So,
instead of
but
N, there is a N plus 2. Yeah.
so like
Hmm.
why aren't you like when you're putting n plus 2 minus 1 r to the power n plus 2 minus 1,
Yeah.
this in the denominator there's that r to the power 2, right? So
Yeah.
why are we not considering that also? So like
No,
if
that you
we
can consider. That also you can consider. But what I was telling was K by R square is a finite number, right? Which cannot become 0 because R is some
okay,
finite distance, right?
yes,
And K is a constant, right? So which cannot become
yes,
0 in the question. And a R power something will be anything. If you take 1 power 0 or anything, it will not become equal to 0, right? If you take
okay,
x
okay,
power something, which will not be equal to 0. So I need not to consider by R square also. I was going 1 by 1 term. So K is not 0, so I cannot consider that. And by R square also cannot become 0. And this part also cannot become 0. So the only part which can become was n plus 2 is equal to 0.
okay,
You
yes,
got my
yes,
point now?
yes,
Yeah.
yes, yes.
N is equal to minus 2. So let's move on to the next question. This you try to do it and tell me the value. This is a straightforward question. For a vector function f, I have given something vector function something like this. Given that vector function is irrotational, then the value of k1, k2 and k3 respectively are. So I already given the vector is a irrotational. So what you need to do, you find the curl of the vector and equate it to 0. Then you will get the constant k1, k2 and k3. So since it is in rectangular, I will write down here. So since it is rectangular, straight away, what is the formula for curl? This is a repetitive thing, what we are doing. In rectangular, you forget about the scaling factors. Ax, ay and az. So dou by dou x, dou by dou y and dou by dou z. And the third row will be the coefficients. You can see the coefficient of Ax, that will be 3y minus k1 into z. And Ay coefficient is k2x minus 2z. And Az coefficient is, see here, there is a minus. Consider the minus. Minus k3y minus z. So you just equate this value equal to 0 and tell me the values of k1, k2, k3. So what you will get? Ax cap into straight away dou by dou y of this term will be straight away minus k3. And dou by dou z of this one, what you will get? Minus 2 minus ay. Dou by dou x of this one, since there is no x term here, it will be straight away 0. and dou by dou z of 3y minus k1z. So that will become minus k1 plus az cap into, so dou by dou x of this one will be straight away k2 minus dou by dou y of this one will be straight away 3 is equal to 0. So on the right hand side, since it is a null vector, so you can equate ax coefficient also to 0, ay coefficient also to 0, az coefficient also to 0. So if you equate the ax coefficient to 0, what you will get? Minus k3 plus 2 is equal to 0. So your k3 becomes straight away 2. And similarly, you can see here ay coefficient is straight away k1. So k1 is straight away, you can equate it to 0. And if you equate the az coefficient to 0, you will get k2 minus 3 is equal to 0. So your k2 will be straight away 3. So k1 is 0 and k2 is 3 and k3 is 2. So 0, 3 and 2. So option B is the correct one. So any questions? Shall I move forward?
Yes, sir.
This question, you see, this is an application of Gauss divergence theorem. So we'll first see the question. So there is a vector he has given 3x square yz into ax cap. Then find double integral d dot ds over a surface characterized by x ranging from 0 to 1, y also ranging from 0 to 1, z also ranging from 0 to 1. See here what you need to do. You need to find out double integral d dot ds. But look at the characterization of the surface he has given. Is it a closed surface or an open surface? Please answer. Look at the dimensions here. Is it a closed surface or it's an open surface?
Closed.
Close.
What will be the reason?
Sir, because limits are finite.
Yeah, limits are finite and at the same time it is bounded in all the directions you can see. So
Yes.
whenever if you say two-dimensional surface or open surface, it is bounded in only 2 dimensions, right? Because in the question I already given x and y and z all are bounded in all the directions where each length, width and height, everything will be equal to 1 meter. So if you see the characterization of the surface, it is nothing but a cube and the cube itself is closed here. So indirectly I was asking you to find out the closed surface integral of the vector d. So generally if you want to do in a conventional method, as I said in the previous class divergence theorem discussion, there are total 6 surfaces are existing, you can see here. X equal to 0 is one surface and x equal to 1, one surface. And y is equal to 0, y is equal to 1. Z equal to 0, z equal to 1. So if you go in a conventional method, you have to calculate the total 6 surface integrals, right? Because there are 6 surfaces are existing here. So instead of doing that, the moment once the surface is closed, you can make an advantage of the Gauss divergence theorem. So what the Gauss divergence theorem says, when the surface is closed, the integral of surface integral of vector d can be equated as the triple integral, the divergence of the vector d into the differential volume. So what is the value here? That is a triple integral. Can you please tell me what is the value of divergence of this vector straight away?
6xyz.
Good. Since there is no only ax coefficient is there, differentiate with respect to x. So del dot d is straight away 6xyz. And please tell me what is the value of dv. So we have seen the differential volume in rectangular system, right? So how to write the differential volume in rectangular system? Did you remember the formula? What I given there?
dx dy dz.
Yes. If it is in a rectangular, there is a change in x, change in y and change in z straight away. So please do the integration and share me the answer. So since it is a homogeneous function, you can integrate separately. So integration of x will be x square by 2 And what is the limits here? You can see here x is ranging from 0 to 1. And y integration will be y square by 2 ranging from 0 to 1. And z integration also z square by 2 ranging from 0 to 1. So that will be 6 into. So straight away we'll get 1 by 2 minus 0. Here also same thing. So we'll get 6 into 1 by 2 into 1 by 2 into 1 by 2. So the answer will be 6 by 8, or you can say 3 by 4. Yeah. So now someone is asking about the questions in divergence theorem. Is it clear for you? I didn't remember your name, please. Now you have understood what is the advantage of the divergence theorem here?
Yes, sir.
Instead of calculating the 6 surface integrals, the problem is solved with only one volume integral. That is an advantage of the divergence theorem, right?
Yes, sir. Contributing it now.
Yeah, you understood right now? Yeah, we will move on to the next question. See here, this is a problem. Read the question again. So there is a vector given in terms of cylindrical, aero cap plus a phi cap plus az cap. Then find integral a dot dl around a closed circular quadrant shown in the given figure. So this is also one of your previous year gate questions. So we'll see the solution for that. So first thing, you can just tell me, since the line is closed, can I apply the Stokes theorem here? Yes or no? Can I apply the Stokes theorem in this case?
Yes, sir.
Yes, sir.
Yeah. Now, please tell me in the same time, since I know the vector A, the moment you start from here to here, you can see the diagram here. So this, when I was moving in this particular direction, what is going to change? Which variation is happening?
X.
Yeah, when I was moving from here to here, what is going to change? Moving from here to here. So let me define it as A and B. So O to A, there is a change in X, right? And A to B, what is the change happening? In which direction the change is happening?
Minus.
Why here?
Minus.
No, no, no. Did you remember in this case of cylindrical system? I already given you. Yeah. When your point is here, what is the value of phi here? 0 degrees, right? Yeah, good, correct. So when you are moving away from this and you try to move on a circular path, you are going to move in a direction where there is a change in phi happen, right? So in other words, when you are moving from O to A also, there is a change in X, fine. I can say the change in X is same as change in rho. Will you agree with my statement, everyone? The change in X also means the change in rho. Will you agree?
Yes, sir.
How it is was, because you already know what is the value of rho, right? In case of cylindrical, rho is equal to root x square plus y square. So whenever the value of x changes, indirectly there will be a rho changes. So what you need to understand here was, when you are moving from O to A and again from A to B and again coming back to O, so there is a change in rho here from O to A, and A to B there is a change in phi, and B to O again there is a change in y. So which I can in turn say change in rho. So instead of talking about x, y and all, I was talking in terms of rho and phi, because you know the vector in case of a cylindrical. So when you move from O to A and O to B, there is a change in rho happen, and A to B, there is a change in phi happen. So using the Stokes theorem, the line integral can be equated to the curl of E A into ds. So first, all of you, please try to find the curl of that vector and tell me the answer. So when you are finding the curl of that vector, so you should take care of the scaling factors. So there is a 1 by rho here, and the first row will be a rho cap and rho into a phi cap comma az cap because of the scaling factor. dou by dou rho, dou by dou phi, dou by dou z, and the third row will be coefficients multiply with the scaling factors. That will be 1 and rho and 1. So what will be the value you will get? 1 by rho a rho cap into, so you will get 0 here, there is no rho coefficient, minus rho into a phi cap, dou by dou rho of 1 and dou by dou z of 1. This also will get 0 plus az cap into, so dou by dou rho of 1, rho will be 1 here, and dou by dou phi of 1 will be 0. So what is the value of curl of A you are getting? There is no rho coefficient and phi coefficient. Straight away you will get az cap divided by rho. The same thing you got, please cross check. Is it correct?
Hello.
Yeah. Is it correct? Yeah. Please ask your question. Yeah.
Yes, sir. Just that row part. I'm again asking. Can you please explain that? Just confused.
Which
That
part?
row part.
Denominator.
Row.
This
That
one. This
why
one.
that denominator part? Why that is coming in this picture? That in the coordinate system.
Correct. In case of cylindrical, if you go to the previous definition for curl, what is the basic definition? You can look at by H1, H2, H3 into, you remember?
Yes.
H1, H1 AU, H2 AV, H3 AW, and second row will be dou by dou U, dou by dou V, and dou by dou Z, right? Third row will be H1 into AU, H2 AV, H3 AW, correct?
Yes.
What is H1,
Yes.
H2, H3 in case of cylindrical? 1 row 1, right? So 1 into row into 1 will be straight away row, 1 by row, right?
Yes.
Yeah, that is the reason why I was repeating in everything. Yeah.
Okay. Fine.
Understood, right?
Yes.
Yeah. Now you tell me the value of ds in this case.
Sorry.
So ds will be that is phi d phi and d rho. That is rho d
First,
phi.
let me write curl of A. Curl of A, you are getting the value will be 1 by rho into az cap. And when you are moving on the surface, what is going to change there? Rho and phi, right?
Yes, sir.
Yeah. So what is the variation in rho? When you are writing the differential surface integral, I already told you. So when you are moving in the direction of change in rho, the variation will be d rho.
Yes, sir.
So what is the variation in phi?
Rho d phi.
Very good. Rho into d phi. And what is the direction of the surface?
A cap z.
Whichever is constant, right? Whichever is not varying. So when you look at that surface, whatever I was moving the integration, so wherever rho is changing and phi is changing, z is not at all changing, right? So that represents the direction, right? So what is the value of integral a dot dl now? That will be double integral curl of a into ds. So that will be double integral. Curl of a will be 1 by rho az cap dot product with ds will be rho d phi az cap. So rho one time gets cancelled and az dot az will be straight away 1. So what is the value you are getting? Double integral d rho into d phi. So what is the value of rho limits?
0 to 2.
Yeah, I have given 0 to 2, right? And what is the value of phi limits?
0 to pi by 2.
0 to pi by 2. Why
Pi
it
by
is 0 to pi by 2? Because already if you read the question, it represents 1/4 of the complete circle, right? You see
Yes.
here, whatever the portion I have written, it is just exactly 1/4. If you divide into 4 portions, it represents only 1/4 of that. So if there is a complete circle, it is having a 2 pi radians. So since it is 1/4 of the circle, the phi value will range from 1/4 of 2 pi. So the phi will exactly ranges from 0 to pi by 2. So do the integration now. What you will get? So integration of d rho will be straight away rho, and this will be phi 0 to 2, and this will be 0 to pi by 2. So what is the answer you will get? Pi.
Sir?
Yeah.
Sir, why the limit for rho is 0 to 2 means it is the shift in x. No?
Shift in X or shift in Y? If you are moving shift in X, what variation you got? Just I will open that slide.
Yeah.
Yeah. If you are moving from O to A, you can see here, there is only variation in X, right?
Yes.
So when you are finding the value of rho, what is happening there? Root X square plus Y square, right?
Yes.
X only changing from 0 to 2. So X will be maximum of 2 and Y will be 0. Yes or no?
Okay. 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 Yeah. Got it.
Similarly, even if you are moving in this direction also, X will be 0, Y will be changing from 0 to 2. So you
Okay.
got
Sir.
the point?
Yeah.
Yeah, right. So this is also your previous year gate question. So now we have seen the advantages of the divergence theorem as well as the Stokes theorem. So the divergence theorem, advantage of divergence theorem will be it reduces the number of surface integrals into one volume integral. And when you calculate the Stokes theorem advantage, it reduces the number of line integrals into one surface integral. So I think this is a problems actually I thought related to the vector calculus. So any questions you have still? So if you have any questions, we will discuss. After that only we'll go to the main core subject of your our EMT. So whatever we have discussed in the previous two lectures, it's all about the introduction part of electromagnetic theory. And of course, that is very important to understand the main core concepts here right now. So we have seen the different types of coordinate systems and the conversion from one type to other type. And in the next part, vector calculus, you have seen the different operators, gradient, divergence, curl, and the Laplacian operator. And you have seen the differential length, area, volume, all these concepts also. So with the help of that fundamentals, we'll try to enter into the main subject. So the third one is the electrostatics part. So we'll start with the electrostatics. So in this lecture, it's a very simple presentation I have made for the better understanding. I don't want to put so many complicated equations and all. So I have taken in the electrostatics part, there are 4 concepts that we are going to understand today. So the meaning was, in this lecture, we will try to understand the electrostatics, and as the days progresses, we will see the magnetostatics also. So initially, we will confine our restriction to both static electric fields and static magnetic fields. So there will be electric fields and magnetic fields. First, initially, we will see and understand the static nature. So can you please tell me, anybody have idea what do you mean by static? So what is that meaning of electrostatic represents? No problem whether it is right or wrong. Just share what you are thinking about electrostatics. What does it mean? Nobody is ready to give the answer. Okay, anyhow. Electrostatics or magnetostatics means static means which are independent of something. So in the first initial part, we will discuss about the electrostatics, which means that the electric field which are not a function of time, or you can say independent of time. So whereas when you go to the wave propagation, you will see if the time varying electric field and time varying magnetic fields are there, how they are going to behave. So the first introductory part will discuss about static electric fields. So which means the electric field is independent of the time, which is a constant electric field and a constant magnetic field. So let us start with the first one. So the basic law in electrostatics is the Coulomb's law. So everybody would have been familiar with the Coulomb's law. So what it says, so when you have two charged particles, Q1 and Q2, separated by a distance of r in any medium, so there exists a force of attraction or repulsion. So that is directly proportional to the product of the charges and inversely proportional to square of the distance between them. So is the force is a scalar or a vector?
Vector.
Vector.
Correct. the force is a vector, Coulomb's law force. So whatever I have written is the magnitude part. We'll see the direction in the next slide. So the Coulomb's law force is straight away you can say the proportionality constant K and Q1 Q2 by R square. So I can say the Coulomb's law force or the magnitude of the force is nothing but the proportionality constant is 1 by 4 pi epsilon and Q1 Q2 divided by modulus of R whole square. So this represents the magnitude of the force between the two charges. So when any two charged particles placed in any medium, it will experience a kind of force that is called the Coulomb's force. That force magnitude is given by 1 by 4 pi epsilon Q1 Q2 divided by R square. So what is basically epsilon is said to be the permittivity of the medium. So epsilon is said to be the permittivity of the medium. So the value of permittivity, you know that it is nothing but epsilon naught into epsilon R. So where epsilon naught is said to be free space permittivity. So what is the value of free space permittivity? Can you tell? Anyone?
8.85 into 10 power minus 12
Units?
farads per meter.
Very good. So 8.854 into 10 power minus 12 farad per meter. But all of you don't remember this one. I will tell you a simple, this value only I will put it like this. 1 by 36 pi into 10 power minus 9. So you try to remember the value of epsilon in terms of pi. So because when you go to the problems, it will be easy for the cancellations and that. So you try to remember this 1 by 36 pi into 10 power minus 9 farad per meter. And epsilon R is said to be the relative permittivity. And the relative permittivity is basically varying from one medium to the other medium. So if it is a free space, the relative permittivity will be 1. And if it is a dielectrics, the relative permittivity will be higher than 1 or lesser than 1. So it will vary from medium to the medium. So first of all, you try to understand what is the meaning of the permittivity. I will give an example for this. So when you say a permittivity, if suppose a particular dielectric medium is having higher permittivity, so which means that that particular medium can easily allow the more electric field through that medium. So the permittivity is basically the ability of the medium to allow the electric field. So if a particular medium is having high permittivity means it can easily allow the more electric field through that medium. So that is what the permittivity means. So soon we will try to understand the permeability also. So it is quite equivalent to that. So the permeability will be the ability of the medium to withstand the magnetic fields. So that time I will explain. So there are different kind of materials which will have more permittivity and less permittivity. If you want to see the example for the high permittivity materials, I can say all examples, I can say all your dielectrics. So suppose you would have been seeing the parallel plate capacitor, right? In case of a parallel plate capacitor, whatever the type of medium present between the conductors will be made up of a good dielectric. The dielectric can be, you can have a mica or paper or ceramic. So whatever the dielectric they are using between the parallel plate capacitor is supposed to have a high value of the permeability. Because you know that in case of a parallel plate capacitor, the permittivity will actually defines the value of the capacitance. If the permittivity is higher means your capacitance will be high. So the example of materials for high permittivity will be either mica or paper or it will be a ceramic. All the dielectrics generally will have a higher permittivity. And at the same time, the ferroelectric materials, there is a different kind of materials available. Ferroelectric materials like nickel zinc is also used to have a higher permittivity material. Yeah. Now, what the Coulomb's law says, and if there are charged particles Q1 and Q2 separated by a distance of r, there exists a Coulomb's law force. But remember here, the Coulomb's law force is significant in this case, provided the mass of the charged particles, or you can say the size of these charged particles, will be much lesser than the spacing between the charges. So I can say the Coulomb's law force will be significant if the radius of this charged particle and the radius of this charged particle will be much lesser compared to the spacing between the charges. Can anybody tell what is the reason for that? So at least one or two people can answer. Am I audible first of all?
Yes, sir, you're audible.
Yeah, so let us try to make it as an interactive session, or otherwise, because it's evening time, right? People are already getting sleep, I think. So try to make the session as an interactive. So the question is here, the Coulomb's law force is significant provided if the radius of the charged particle is much higher than the separation between the charges. What could be the reason? Somebody's written, I think that R is generally taken as infinite. No. R is a finite distance. Let us like 1 meter or 2 meter also, there exists a Coulomb's law force. Okay, let me explain. See here, whenever if there is a charged particle or something, if there is a particle which is available, always there will be a gravitational force which will be existing, right? So what is a gravitational force? The force due to the gravity. The force due to the gravity is mass into acceleration, right? So what will happen if the radius of the charged particle is getting high? Which means that the size of the charged particle is more. In other words, the mass is very high. So suppose if the radius of the charged particle is much higher than r, which means that mass is sufficiently high. So when the mass is very high, the gravitational force will be dominating, right? So the charged particle is trying to attract because of the gravitational force. So in this case, gravity will be the dominant force. Or your Coulomb's law force also will be existing, but compared to the Coulomb's law force, the gravitational force is much higher in magnitude. So that is the reason why when the mass of the charged particle is quite high, you can say that Coulomb's law force is insignificant. So it doesn't mean that Coulomb's law force is not existing at all. Coulomb's law force is existing, but the gravitational force is quite dominant force there. So you got the point?
Yes, sir.
Yeah, somebody is asking me to repeat. So what I was telling, so if the mass of the charged particle is quite high, so you know that gravitational force will be mass into acceleration. So when the mass is very high, your gravitational force is quite high. So what will happen compared to the magnitude of the Coulomb's law force, this gravitational force is getting dominating. So you can say that Coulomb's law force is insignificant. What will happen if the radius is much lesser than the separation between the charges? So since radius is small means your mass will be small. So your gravitational force can be neglected. Generally, in other words, let me give a simple example. If you see the textbook, any textbook, they will say that the Coulomb's law force between the electrons, like that only. So what will be the mass of the electron? 9.31 into 10 power minus 31 kg. You can see here this will be in the order of 10 power minus 31, which will be quite very negligible. So when the mass is very negligible, you can ignore the gravitational force. So the Coulomb's law of force is significant whenever this mass is something like this, which is quite negligible compared to the separation between the charges. Now you got Deepanshu. Yeah, we'll go to the presentation part again. Just a minute. Just a minute, I was uploading the presentation. By mistake, it has deleted. Yeah, we have seen the Coulomb's law force. So the Coulomb's law force magnitude will be, straight away I can say once again, the force will be 1 by 4 pi epsilon and Q1, Q2 divided by R square. and the value of epsilon will be epsilon naught into epsilon r. And at the same time, the units of the Coulomb's law of force will be, since it is a force, the unit will be in the order of newtons. So this is summary, and next moving on to the next concept. Look at the direction. So in the first case, you can see here, there is a two charges, Q1 and Q2, both are positive. So what will be the direction in this case? So since this is also positive, this is also positive, so this force will be trying to move away from Q2, and Q2 also will try to move away from Q1 because of the repulsive force. So whenever the polarity of the charged particles are same, they try to move away from each other. So that's what it says. When the polarity will be like charges, they try to repel each other. The same case, even if it is both negative also. If the same charge is, same polarity is present, they try to move away from their original position. And what will happen if we see the unlike charges? So one will be positive, one will be the negative. So this positive charge is trying to attract towards this negative charge. So this, if we see the force on Q1, it is trying to move towards Q2. And similarly, Q2 is also trying to attract towards Q1. So the unlike charges will be trying to attract each other. So the direction of force on Q1 will be towards Q2 in this case. And the direction of force on Q2 will be towards Q1. So both are trying to attract each other. So this slide actually defines what will be the direction of force on each charge. So if both are like charges, the direction of Coulomb's law of force will be away from each other. And when it is unlike charges, both are trying to move towards. So both are trying to move in the opposite direction, something like this. Clear? Shall I move on to the next one?
Yes, sir.
Okay. So with the understanding of the Coulomb's law of force, we will try to discuss one more very, very important parameter called electric field intensity. So what is actually an electric field intensity means? So electric field intensity is also a kind of the force experienced by a unit positive charge. So to give an example, I have given the diagram here. You can see this. So you can see here, this is a particular medium. Only there is one charge is located here. With the help of simple elementary physics, we studied every charged particle is trying to create a flux, right? So there will be a flux which will be located in all the directions, something like this. Now, if you want to find out an electric field intensity at any particular point, something like this, what is the definition I given? So whenever there is one charge is existing in a particular medium and you try to bring another 1 Coulomb charge into the same medium, what will happen now? This 1 Coulomb charge is trying to experience a kind of force due to the existing charge Q. That's what your Coulomb's law of force says. When you try to introduce a new charge into the same medium where already there is some charge present, this new test charge is going to experience a kind of force. So what we have given the electric field intensity definition was, this is a kind of the force experienced by a unit positive charge. Suppose this is the position where I want to define my electric field intensity. So electric field intensity is just a measure of how much field is existing at that particular point of interest. So wherever you want to find the electric field intensity, just imagine that there is 1 Coulomb charge is existing there and apply how much force is existing on this unit Coulomb charge. So the magnitude of the force experienced by this 1 Coulomb charge is nothing but the electric field intensity. So first of all, to understand about this, what is the Coulomb's law says? The magnitude of the force will be Q1 Q2 divided by 4 pi epsilon into r square. So if you look at the definition for electric field intensity, the magnitude will be what? Q1 is straight away Q, and instead of Q2, you can replace the value of Q2 with a 1 Coulomb. As I said, wherever you want to find the electric field intensity, imagine that 1 Coulomb charge is existing. So this is same as the Coulomb's law of force, where your Q1 will be original charge and Q2 will be 1 Coulomb. So what will happen in that case? Q divided by 4 pi epsilon r square. So this gives the magnitude of the electric field intensity. So can you tell me what is the unit of this?
Volt per meter, sir.
Volt per meter, or any other units?
Newton per Coulomb.
Yeah, Newton per Coulomb, because the reason is it is a force experienced by a charge, right? So the electric field intensity is basically the force per unit charge, where Qt is 1 Coulomb now. So force is in the order of Newton and the charge will be in the order of Coulomb. So you can say either it is a Newton per Coulomb, or in your EDC also will study electric field intensity is the voltage per unit length. So that is the reason why you can say volts per meter. So is the magnitude part and this concept you understood? What do you mean by electric field intensity? So once again, I will put it in a simple words. You don't think it too much about the electric field intensity. So the electric field intensity at any point is a measure of field at that particular point of interest. So here what you need to understand was, wherever the original charge is located, that position I was considering it as a position of the source. So when I say the source means the position where the original charge is located. And there is one more terminology I have given it as an observer. Observer is the position where you are finding the electric field intensity, right? Is the difference clear?
Yes, sir.
Yeah. This source and observer, if you clearly understand, the direction part is very, very easy. So source is the point where the original charge is located, and observer is the point where you are finding the electric field intensity. What is the position where you are placing the 1 Coulomb charge? That is nothing but your observer. So you can see the note here, the direction of electric field intensity purely depends upon the polarity of the charge, right? We'll see what is the direction right now. The next slide. What will happen if the polarity of the Q is positive? See here, this is my source, and the source is a positive charge. And my observer is always, observer means you have to place a positive 1 Coulomb charge there, right? So what will happen? When you are finding the electric field intensity, you should always concentrate on the observer only, because you are finding the, or you are determining the force experienced by the 1 Coulomb charge. So what this 1 Coulomb charge is trying to do now? So since this is also positive and the source is also positive, so the 1 Coulomb charge is trying to move away from the source. So both are positive charges, right? So the 1 Coulomb charge is trying to move away from the source. So in this case, what is the direction of electric field intensity? So electric field intensity direction will be like this. So I have mentioned something like this. So when the polarity of the charge is positive, the electric field intensity direction will be radially away from the source. In other words, this charge Q is pushing the 1 Coulomb charge to move away from the position. So when the polarity is positive, the electric field intensity will be source to observer. You can see here, this direction will be same as source to observer. You can extend it down. And what will happen when the polarity is negative? So since it is negative and the observer is of positive type, so 1 Coulomb charge is trying to attract towards the source. So it is trying to move towards the source. So when Q is negative, when the charge is negative, this 1 Coulomb charge is trying to move towards the source. So when Q is negative, the electric field intensity will be radially towards the source. In other words, the observer is trying to move towards the source. That is from observer to source. So let me summarize. You need not to think too much here once again. If the charge is positive, the electric field intensity is from source to observer. If the charge is negative, the electric intensity is from observer to source. So try to get if you have any doubt, try to get it clarified now only. So point number 1, source and observer. Is it clear for you? What is source and what is observer?
Yes, sir.
Clear? Yeah. Now, when the charge is positive and when you are defining the electric field intensity, it is nothing but you try to concentrate only on the observer position, right? So when the charge is positive, when the observer is here, and since it is positive charge, it is moving away from the source. So when the charge is positive, electric field will be away from the source. In other words, source to observer. When the charge is negative, the 1 Coulomb charge is trying to attract to the source. So it is radially towards the source. So direction part, is it clear finally?
Yes, sir. So can we
Yeah.
conclude that the the direction is always from positive to negative, or that
Positive to
depends on
negative.
the
See,
intensity?
if you see the first case, see, both are positive only, right?
Yes, sir. So if they are oppositely charged,
That is the reason.
then
You can see whether it is polarities, both are plus or both are minus. And at the same time, you should concentrate only on the observer, right? Because electric field intensity is the force experienced by the observer itself. So you see the position of the observer and polarity of the source. So both are positive means observer is trying to move away from the source, right?
yes, sir.
If the source is
Yes.
negative means observer is trying to attract towards the source. That is the reason. Simple. If the charge is positive, 1 Coulomb charge is trying to move away from the source, which means that source to observer. If the charge is negative means it is trying to attract towards the source. So it is from observer to source. Clear?
Yes, yes.
Yeah, we'll move on to the next slide. So we have seen the Coulomb's law of force, and then we have understood the basic parameter called electric field intensity. So the electric field intensity is just a measure of the field. In other words, you can say the force experienced by a unit positive charge placed at that particular point of interest. So now, first of all, we will see what do you mean by an electric flux. So electric flux, if you see the William Heath textbook, if you have any free time, you try to go through the textbook. So in that textbook, he has already given a detailed explanation about what is actually an electric flux. And for that, he has done one Faraday's. Anybody remember the Faraday's experiment? So when I say the Faraday's experiment, people used to remember in terms of that the change in magnetic flux will produce the induced EMF, right? So that is basically the Faraday's second law. When you see the Faraday's first experiment, so actually Faraday is a professor in Royal University London. So this was an experiment that what actually he has done, and he is actually formulated what is the definition for electric flux. So we'll try to understand his experiment. So what he has taken two concentric spheres. So you can see here, this is a sphere which has been given a known charge. So the inner sphere is having given with a finite amount of the charge. And then he tried to enclose the inner conductor with an outer conductor, something like this. And the outer conductor is made up of two hemispheres, something like this, and which will be clamped together. So I will tell you why he has considered the two hemispheres for the outer part. You will understand it soon. So first, inner sphere has been given a charge of q coulombs, and he tried to enclose the inner conductor with an outer conductor, something like this. Now, what is the conclusion he found was, whenever he is trying to enclose an inner conductor with an outer conductor, the outer conductor is also distributed with the same amount of the charge. That's what he found it the moment once he connected the outer conductor to ground. So when any charged particle is enclosed by any other surface, it doesn't matter what is the type of medium present between the conductors. The observation what he has given was the charge on the outer conductor is same as the charge on inner conductor, but with a minus sign. Can you tell me the reason why it is minus sign? The inner conductor is of charge q coulombs. Yeah, please. Yeah. What will be the reason?
So the direction is opposite.
If we see the definition what he has given, it's very interesting thing. What is the concept he has given? The moment once the inner conductor is closed by an outer conductor, there is some sort of displacement that is happening from the inner conductor to the outer conductor. So this is something like this. This is a kind of the displacement from inner conductor to outer conductor. This electrical displacement, he called it as flux. So whatever the electrical displacement happening from inner conductor to outer conductor, he named it as an electric flux. So you can say that electric flux is something a kind of a field which is coming from one to other. So since the inner conductor is generating the flux and the outer conductor is inducing the charge. So one will be delivering the source and the other one will be absorbing. So whichever is delivering will be obviously the positive charge if you consider in networks also. And whichever is absorbing that energy, that will be the negative sign, right? So the same amount of charge will be induced on the outer conductor also, but with a negative sign. And this case is valid, and he given one more point you can see here, even irrespective of the type of dielectric present between the conductors. So between the inner conductor and outer conductor, even though if it is free space or even though if it is a finite dielectric medium, it doesn't matter. The flux will displace from inner conductor to the outer conductor. So the electric flux is the displacement from the inner conductor to the outer conductor, and the charge on the outer conductor is negative of the charge on the inner conductor. And he given, you can see here the electric flux is same as when you add the sum of all the total flux lines. Can you tell me what is the sum of the total flux lines?
The sum means like flux lines means charge.
I was talking about magnitude of the flux. What is the total sum of magnitude of the flux?
0.
It will not be 0. If you see here,
Okay.
you can see here the electric flux is nothing but a charge itself. That's it. You need not to think too much. So here the electric flux is same as charge. So when you try to add all this flux, whichever is generated from the inner conductor, you will get exactly same as the charge on inner conductor. So as of now, you can remember electric flux is same as the charge. Is it clear? Yeah. So that's what I given. So since electric flux is same as charge, the unit of the electric flux is also measured in coulombs. Is that correct?
Yes.
And now see here, is this slide clear for you? Anything needs to be explained? So the final summary is when you try to enclose any inner conductor with an outer conductor, the same amount of charge will be induced on the outer conductor also with the equal and opposite magnitude. In the same case, what is the net flux leaving the inner conductor? Can you tell me what is the net flux leaving the inner conductor? Can you tell me what is the value of net flux leaving the inner conductor?
The charge of the inner conductor.
Yeah, is it plus Q inner or minus Q inner?
Plus.
Exactly.
Q.
Yes,
Okay.
Yes, sir, outwards. Yes, sir.
I already given it's a leaving, right?
Yeah.
You need not to consider the minus sign here. So whatever, when sometimes in questions they will ask you something like this. So there are 3 concentric spheres, something like that. When you want to find out the net flux leaving the outer conductor, whatever the net flux leaving the outer conductor, if we say in that case you should not put minus Q inner, right? If they say find out the charge on the outer conductor, then you put minus Q inner. You got my point? If in the question, if they ask find out what is the total amount of charge induced on the outer conductor, then you can consider minus Q inner. Or in other words, if they say find out the net flux leaving the outer conductor, which means that you should not consider minus there because already leaving itself indicates minus. So the net flux leaving the outer conductor is same as Q inner. So is the concept clear for you? This one?
Okay, means it, both case it will be always like plus Q.
Magnitude wise same only. But if the question is specific about how much charge is induced on the outer conductor, it will be minus Q, right?
Okay.
But if the same question is framed in a different way, how much flux is leaving the outer conductor? Whatever the flux is leaving the outer conductor means leaving itself, I already consider minus, right?
And it escapes out of the outer conductor, or it is like absorbed by the outer conductor. So
Net flux leaving or passing through the outer conductor, they will say. Because see, sometimes the outer conductor may not be purely a metal. In that case, what will happen? The flux will pass over the surface. Right? So that is the reason why the net flux leaving the outer conductor will be exactly same as Q. You should not consider minus because it is already leaving, right? Is it clear?
Yes, sir.
Yeah, we'll move on to the next one. So we have seen Coulomb's law of force, electric field intensity, and electric flux. Now we will see the concept of electric flux density. So for that also I have given the same example you can see here. So this is one inner conductor given a charge of Q. So I try to enclose the inner conductor with an outer conductor. So as I mentioned, there is a charge of minus Q which is induced on the outer conductor. So the inner conductor is having a radius of A and the outer conductor is having a radius of B. So in this case, when you want to define the flux density, first of all try to see what is the flux density means. So you can see here, if there is a point charge something like this, the flux will be omnidirectional, right? The flux density will be refers to a particular surface. So now the flux is generated in all the directions. So let us imagine I have kept a particular surface here, something like this. So do you think the total flux originated from Q will pass through this surface?
No, sir.
No, the reason was because whatever the surface I have considered is not closed surface. So what will happen? Whatever the flux generated from the charge, only a portion of the flux will be passing through this surface. So in this case, the flux density will be defined as how much flux is passing through this surface divided by the area of the surface. Understood?
Sir, could you repeat this?
Yeah. So when you have any charged particle, it will produce the electric flux in all the directions, right? But
Yes,
the
sir.
flux density will be defined with respect to a particular surface.
Okay.
Now, if I assume that this is a surface where I have placed something in a medium like this, do you think the total flux is passing through the surface or only a small part of the flux?
Okay. Small part. Yes, sir.
Yeah. So the flux density will be defined as how much flux is passing through this surface divided by the area of the surface.
Okay.
Is it clear now? Suppose in other
Yes, sir.
words, if I have a point charge something like this and you try to enclose it with a closed surface. So what will happen in this case? The total flux will be captured. Is there any flux
Yes.
lines which is missing out?
No.
So that depends on the surface, right? It depends on the surface characteristics. Always surface may not be closed. So the flux density is a basic term which represents the electric flux passing through a given area. So the units will be, since it is flux per area, you can say Coulomb per meter square. Now, so with this, we'll try to find out what is the flux density on the inner conductor. Can you tell me what is the flux density on the inner conductor? Anybody?
Q by pi a square.
Pi a square, huh? Sure? Huh? This is sphere.
Oh, okay. 4 pi a square.
Right. So if you see the inner conductor, there is a total charge of Q, right? So whatever the flux is existing on the inner conductor will be Q divided by. So the area of the inner conductor will be, since it is a sphere, the surface area will be 4 pi r square. So in this case, R is nothing but A on the inner conductor. So when you calculate the flux density of the conductor, the total amount of the flux divided by the area gives the flux density. So similarly, what is the flux density on the outer? Please tell me.
So Q by 4 pi B minus A.
Just I was saying the magnitude, right? So there is a minus Q. Of course, I was not considering. It is a magnitude. Q by 4 pi B square. Now the next thing. So if you are understood properly, try to tell me the answer for this. So I have considered a small Gaussian surface, which is an imaginary surface between the conductors at a distance of r. What will be the flux density on that Gaussian surface? So when you consider a value of r lies between A and B. Now I consider some imaginary surface between A and B. What will be the flux density at that point? Anybody? You can see here clearly, when you consider an imaginary surface, how much flux it is capturing? Is it closed surface or open surface? Whatever the imaginary surface I have considered.
Closed.
So since it is closed, how much flux it will capture?
Charge enclosed in it divided by its
Inner conductor, right? How much charge is there inside that
Q.
closed surface? So within this charge, how much is charge present? Q, right?
Yes, sir.
Yeah, Q divided by what is the surface area of that?
4 pi r square.
That's it. So at any radial distance of r, the flux density will be the charge divided by the area, Q divided by 4 pi r square. So is it clear the
So,
density now? Yeah.
so like in that imaginary line that you said that r radius, like the entire Q will be going there. Isn't it
Exactly, right?
depend
Because
on?
the surface is closed. Whatever the surface I have given, you can see here the pink color. It is fully closed, right? Fully closed.
Okay, so if it is fully closed, then it will be the entire Q will be there.
Entire Q. That is the reason why I was considering Q divided by 4 pi r square. As long as the surface is closed, whatever the flux leaving that conductor will be same as the charge which is enclosed. Clear?
Yeah.
So
Yeah.
suppose it's
Yeah. One person you can ask, no problem. Yeah.
so suppose that like if it was not a closed surface, say if it was maybe half this thing.
In that case, actually there is a different method. We'll see that problem. The moment
Okay.
once the surface is not closed, you should not consider it as a Q.
Okay.
So you should consider based upon what is the surface area of that. So accordingly, proportion of that will be considered. We'll see in the problems. Your question will be answered while discussing the problem.
So
the
for
thing is,
Gaussian process also the Q will be negative, right?
yeah, it will be negative. But whatever I was saying it to till now is just only the magnitude part. Yeah. And the next thing, when you want to consider the direction of the electric flux density, it is same as your electric field intensity, right? What the reason? So we have studied in our physics, right? The electric flux density is basically equal to epsilon times E. This is a well-known relation, right? We already studied. So the electric flux density and the electric field intensity both are lies in the same direction. So, and we already studied epsilon value will be epsilon naught into epsilon r, and epsilon naught will be 8.854 10 raised to minus 12 farad per meter, and epsilon r is the relative permittivity. So is the concept clear? Electric electric flux density. Any questions still? So in summary, I can say the electric flux density is basically same as the electric flux per area, right? So what is the condition? You can imagine that there is a point and you try to enclose this point charge. So now I want to calculate what is the net flux leaving the surface. Can you tell me mathematically? I know the flux density. I want to calculate what is the flux leaving this surface right now. Mathematically, how can you put that?
Charge into area, sir.
Which means flux density into area, right? So if you want to
Yes,
calculate the net flux, see, if you want to calculate the net flux, it is nothing but the flux density multiplied with area. So I can say that the flux density is nothing but double integral. Area vector can be written as double integral d dot ds. So this is the net electric flux leaving through any surface. So is the point clear for you in mathematical form? If the surface is, somebody asked right earlier, if the surface is not closed, how to calculate the flux? The moment once you know the flux density, differentiate over the complete surface, you will get the total flux. Is it clear?
Yes.
Now try to answer me this question. So since you have come to this point, so there is a point charge of Q and I was enclosing this point charge with a closed surface. So what is the net flux leaving this surface right now? what is the net flux leaving this surface? Can you tell me what is that? So there is a point charge Q. I try to enclose with a closed surface, something like this. What will be the total amount of the flux leaving this surface? Mathematically, what is the meaning of that? Is the surface open here?
The Q will leave the surface, sir.
Whatever the surface is closed, so what is the value of psi? It is indirectly double integral d dot ds.
Yes, sir.
But this case, the surface is closed, right? This is what I have to find out. So whatever I have written, is this, you understood everything or any question you have? So you know that if you want to calculate the flux, that is a flux density into area.
Yes,
And by meaning of this one, if you consider, this is a closed surface. This is the value of this total flux. We have already seen whenever any point charge is enclosed by a closed surface, is this able to capture the total flux? Yes or no?
Yes, sir.
So what is the sum of total flux? The sum of total flux is same as the charge, because I already told you flux and charge are interrelated.
Yes.
So the amount of the net flux leaving the surface is exactly equal to Q. Will you agree with my point here?
Yes, sir.
So this is one of your Maxwell equation, right? So we don't require any such a complicated mathematics. Just simple, with the help of simple physics, you can understand, you can derive easily one of the Maxwell equation. This is your first Maxwell equation. So you understood? When any point charge or any charged particle is enclosed by a closed surface, the amount of the flux leaving the closed surface will be exactly equal to the charge which is enclosed in it. So this is also said to be the Gauss law. So have you understood the Gauss law right now?
Yes, sir.
So the Gauss law states that if any charged particle is enclosed by a closed surface, the net electric flux leaving the surface will be equal to the charge present inside. Now, in the same equation, suppose if I write like this, double integral d dot ds is equal to q, corresponding to this, is the statement correct or wrong? This statement.
Sir, it is correct only for closed surface.
Correct, exactly. So whenever anybody says Gauss law, the surface has to be closed. The surface is not closed, you may not be able to capture the total flux. So the Gauss law is applicable only for the electrically closed surfaces. So whenever you are applying any Gauss law in the problems also, you think that that surface should be very close. So clear, have you understood the concepts now? Shall we move on to the problems related to this?
Yes, sir.
Yeah.
Sir, can you just dictate that statement? So that Gauss law statement.
Gauss law, na? Okay, I will write it down here. So what is the Gauss law says here? The net electric flux through any closed surface is equals to the charge enclosed in it. So in a mathematical form, what it says, the flux density multiplied with the area surface is closed is equal to the charge enclosed, Q enclosed. So this is your Q and this is your surface. Is it okay?
Yes, sir.
Yeah. Then we'll move on to the problems, right? So you understood the concept of electric field intensity and the electric flux and the electric flux density. So all the concepts clear, right? So then we'll move on to the problematic part. So since we don't have any time, we'll try to move. So read the first question and try to solve. You take your time, not a problem, but try to tell me the answer. So is the screen is visible to everyone, like everything? Is the content is visible?
Yes, sir.
So please read the question and try to tell me the answer. Now you know the concept and try to apply that. So if anybody is ready, you can message the answer here in the chat. So there are two charges of equal magnitude are separated by a finite distance. If the magnitude of charges are increased by 10%, to get the same force between the charges, their separation will be. So there are two charges, both are Q only. You can say I was considering as since it is same charge, equal magnitude he told, I have assumed both are of magnitude Q and the spacing is R. So what will be the force in this case? The force in this case will be straight away 1 by 4 pi epsilon. I can take it as a constant K into. So Q1, Q2 means Q square divided by R square. So where K is nothing but 1 by 4 pi epsilon. Is it correct? Answer me, is it correct?
Yes, sir.
Yes.
Anybody done? What is the answer? Can you share? Increase by 10%. Correct. See. So since of both are of same magnitude, what will happen? The force is directly proportional to Q by R whole square. Right? You can see the equation here. So F proportional to Q by R whole square. Now what he has given? The magnitude of the each charge is increased by 10%. So what is the meaning of that? Right now, Q becomes 10% increment means 1.1 times Q. Now, to get the same force between the charges, their separation will be. So I want to get the F remains constant and Q is incremented by 10%. So Q becomes 1.1 times Q. So then when the force remains same, R also should become 1.1 times R. Then only your force remains constant, right? Because F is right away proportional to Q by R. So if Q is also increases, R should increment the same proportion to get F as a constant. So if Q becomes 1.1 times Q, R also should become 1.1 times R so that the force is right away proportional to Q by R whole square. So if Q is incremented by 10%, R also should be incremented by 10% to get F remains constant. So the answer will be R also should increase by this 10%. So we'll move on to the next slide, next question. Any questions? You can answer in the message box if you have any queries. Okay, see the next question. So there are 2 point charges, 3 nanocoulombs and 4 nanocoulombs are located at 003 and 040 respectively in free space. Then find the force experienced by 4 nanocoulomb charge. So whatever they have given, I will try to put it in a diagram. So 3 nanocoulombs is located on the z-axis, right? You see 003. And 4 nanocoulomb is located on y-axis. You can see 040. So you can take this is your z-axis. And this is your y-axis. So there is a 3 nanocoulombs located here at 003. And there is a 4 nanocoulombs located here 040. So you need to find the force experienced by the 4 nanocoulomb charge. So first see here, I will not find out the magnitude part. I will find out the direction part. So this is, what is the distance? This one is 4 meters, right? You can see here, this one is 4. And this one is nothing but 3. So what is the separation between the charges right now? Is 5 meters. So this is 4 and this is 3. So the separation between the charges is exactly 5 meters. Root over 3 square plus 4 square. Now you are finding the force experienced by 4 nanocoulomb charge. See here, this is your 4 nanocoulomb. This is a positive and this is also positive. So first part is find the direction of the force on 4 nanocoulombs. So what will happen now? Since both are positive, this 4 nanocoulomb charge is trying to move away like this. So I can represent the direction by a vector along this particular direction. So you can see here, this direction is same as this direction. Will you agree with me? Please concentrate here. This is very important. So whatever the direction I have considered here, I was exactly doing this one. Is both are same or different?
Yes, sir.
That means the both are same, right? So I can consider this as something like a r bar vector. So in the first class I told you, is the direction represents the original vector or a unit vector? So when you want to find the direction, always you should concentrate on
Unit vector.
unit vector. So how to find the direction right now? This represents unit vector along r bar. So what is the unit vector along r bar? The unit vector along r bar is r bar divided by modulus of r bar. So can you tell me what is the value of r bar? So you can see here, this is r bar and this is your end point, you can say, and this is your initial point. So to find out any vector, you can say that is the end point minus original starting point. So end point is 0, 4, 0 minus initial point is 0, 0, 3. So first write down that 0, 4, 0 minus 0, 0, 3. So tell me what is the magnitude you will get. So there is no x coefficient, right? And straight away you will get 4 ay cap and minus 3 az cap. And what is the magnitude of r you got? How much?
5, sir.
5. So what will be the unit vector right now? So ar cap will be 4 ay cap minus 3 az cap divided by 5. So this represents the direction part. So you do the magnitude part. You know the magnitude part, right? So the magnitude of force will be straight away 1 by 4 pi epsilon and q1 q2 by r square. You can substitute the value and you can tell me. So that is 1 by 4 pi. Since the charges are located in free space, the epsilon value will be 1 over 36 pi into 10 power minus 9 into q1 q2 values also you can substitute 3 into 10 power minus 9 into 4 into 10 power minus 9 divided by r square will be 25. So please solve that and finally tell me the answer. What is the value? Actually, I was unable to write here on my iPad because of some network connection, I guess. So please do it of your own and tell me the answer. What is the magnitude?
So 4.32 into 10 to the minus 9.
Good, very good. So you can, all of you cross check, please cross check. I was writing straight away 4.32 into 10 power minus 9. This is your magnitude, newtons. All of you please cross check it whether this is correct or not. So this represents the magnitude part and this is the direction part.
Yes, sir.
Any question?
25. Yes, sir.
Same, right? So we'll move on to the next question then. Final one. See here, this is a question you see. Read. Everybody read that. So there is a point charge of 3 nanocoulombs located at 003 in a medium having relative permittivity 4. So then find the electric field intensity at 000. So when any problem is given, first of all, my suggestion was try to put it in a diagram. You can easily get the answer. So there is a 3 nanocoulomb located at 003. So which means on the z-axis. So this is your z-axis. And the 3 nanocoulombs is located here. So this will be 003. And then you need to find the electric field intensity at 000. So 000 means somewhere here. This is the origin, right? So can you tell me what is the source here and what is observer here, everyone?
The source
So
is 3
observer
nanocoulombs.
is different.
Good. Source is 3 nanocoulombs and observer location is
000.
origin. So what is the condition I told you? In case of electric field intensity direction, if you want to speak, can you tell me what is the direction, anybody?
Minus 3 AZ cap.
Minus AZ cap. Why? Because see, as the source is positive, given 3 nanocoulombs is positive. If the charge is positive, the simple shortcut I told you, the electric field intensity is from source to observer. So right now, when you move from source to observer, you are moving downwards. So the moment when you move downwards, you are decreasing the value of z. So which means that z value will come down. So the direction will be straight away a unit vector along negative z. So the direction part is straight away minus az cap. Is it clear? Direction part?
Yes, sir.
Yeah. Can you find out the magnitude now straight away? What is the magnitude part? So magnitude part will be straight away q divided by 4 pi epsilon square. Right? Actually, it is same as the Coulomb's law of force, where Q2 is 1 Coulomb. So you have to imagine that 1 Coulomb charge is existing here. And you can see here the spacing between the observer is 3 meters. So you can substitute the value. So Q will be 3 into 10 power minus 9 divided by 4 pi. And what is the value of epsilon here? You know that epsilon is equal to epsilon naught into epsilon r. Right? So 4 into 1 by 36 pi 10 power minus 9 into r will be magnitude will be 3. So r square will be 9. So can you find the magnitude now? So what is the magnitude you got?
So 36.
36, huh? Sure, huh? Cross check once again.
You're getting 3 by 4.
Yeah, 3 by 4, right?
Yes, sir.
3 by 4. Yes, you can see here. Pi one time gets cancelled, 4 9 times, and this 9 also get cancelled.
Yes,
So 10 power minus 9 gets cancelled. Yeah, 3 by 4. So if you want to write the resultant electric field, that will be 3 by 4 means 0.75. And the direction will be minus az cap. And what is the units of that? That will be volt per meter. So this is how you have to write magnitude, direction, and unit. So is it clear?
Yes, sir, clear.
Okay, one more problem shall we solve for today? So we'll go through the next problem also. Okay, anyhow, this I will do it in the next class, not an issue, because I had some issue with the writing. So I was not finding it comfortable. Maybe by the next time it will be resolved, I think. So in this total, whatever we have discussed in this today's lecture, it's all about electrostatics. You can see the summary. So in the electrostatics, we have seen the Coulomb's law of force, and we have seen the direction of the force also. And what is the important point you should remember was the Coulomb's law of force is insignificant if the mass of the charged particle is high. And moving on to the next discussion, what we had was the electric field intensity. So that basically says what is the measure of the field at a particular point of interest. So the magnitude of the electric field intensity is same as the force experienced by a 1 Coulomb charge placed at the point of interest. And then we have moved on to the concept of the direction of electric field intensity. So what is the summary we got? When the charge is positive, the electric field intensity will be away from the source. And when the charge is negative, the electric field intensity will be towards the source. And then we move on to the electric flux there. So electric flux is basically same as the charge. So in other words, it is the displacement from one conductor to the other conductor. And the next, finally, we have discussed about the electric flux density. So that is basically the amount of the electric flux passing through a particular area. Suppose if any charge is enclosed by a closed surface, the net flux leaving the closed surface is exactly same as the charge present inside it. So that is what one of the Maxwell equation we have seen. So in this part, if you have any question, please ask me now. We'll try to clarify.
Sir,
Yeah.
there is the electric field intensity and electric field both are like same.
No, when I say electric field, there are two concepts will come: electric field intensity and electric flux density. Both are a measure of electric field, right? But whereas when I say an electric field intensity, it is mentioned exactly at a particular point of interest. Whereas electric flux density is a measure of field through a surface. So generally, when I say an electric field, basically electric field intensity is also one of the parameter and flux density also another parameter. But electric field intensity is at a particular point, whereas electric flux density is through a particular surface. That is the only difference. Both are electric field, but you have to be more specific whether it is intensity or flux density. Clear?
Yes, sir.
Yeah. Any other questions? Somebody saying, so we'll get the assignment for the previous topic. So I already told you, right? Previous topic is just only the introductory part. So for this, your whatever the main core subject start, no, electrostatics, you are going to get the assignment for this. Because if you want to solve these problems, you have to apply the knowledge of that coordinate system and vector calculus. You already seen, no, in these particular problems and all, we are applying that vector calculus only. So for the introductory part, there are no more special assignments. From this part onwards, we will get once the topic is completed, then we will try to discuss the assignment also. So any other questions? So on the next class will be on the Sunday morning 9:30, I think. So by that time, so whoever has not attended coordinate system and vector calculus also, please try to go through the video lectures. And if you have any questions, we will discuss in the next class. That is not a problem. And make sure that all the concepts will be well understood by you. If at any point of time, if you are not able to catch, maybe in these sessions like that, you can clarify your doubts. So any more questions, or else we can. So should we conclude the session now? So still there are so many problems are there. I thought I can discuss today, but since there is no time, we'll start with the problems in the next session. There are another some 10 to 15 problems were there. I thought I can discuss now, but since this writing is not clear and since time is also not there, so we'll try to conclude the session here. And in the next class, we'll continue the problems of this topic only. So by that time you go through the theory part, and are you going through the PDF that I was sharing it to you? Are you getting that
the
PDF
same
file?
PPT. So
Yeah,
the same PPT
PPT
that.
one. Because actually some people said, right, because it is very difficult to go through the complete video. So as a part of theory reference, that I have been forwarding it to you. Is it helpful?
Sir, you're uploading in
Yes,
the
sir.
Google
Yes.
Drive or it's there
I was
here in the.
uploading in the Google Drive because Dinesh sir has shared any link to you?
Okay, I will check.
Because I was
Let
uploading in the
me
Google Drive. Maybe everyone can, I think I will inform to Dinesh sir also. He might be sending that link also. So the
Okay,
moment,
sir.
because sometimes if you feel that only one particular topic you are not understood, so better to go through the PDF also
Yes.
simultaneously. So that gives a clear picture. Whatever I have mentioned the theory, right? That is everything written in that PDF. So if you are feeling it comfortable, then I can continue the same for the next classes also, based on
Yeah,
your
yeah.
feedback. That's
Yes, sir. Yes, sir.
yeah. Okay, then that's all for today. We can sign off now. Then see. Good night. Thank
sir,
you.
could you
Yeah,
just
yeah.
uh,
Hmm.
could you just post the maybe questions also when you the PDF?
In PPT
We
format.
can
Huh? No,
yes,
actually, the thing is, what
anyway,
I was
PDF or
doing
PPT.
was whatever the questions is there, as a question part is concerned, I was already posting it in PDF. But explanations also to be in PDF. Huh? Hello.
Like in just a few before the class.
Yeah, you want the solution.
Hello.
Solution also should be mentioned in PDF, right? Actually, till now I have done the theory part. Maybe anyhow, I can do that also. That is not a problem.
No, sir. Only
That,
the questions also. If you post, it's enough.
no, only questions already there. Questions already there in the drive. Maybe I have not forwarded to Dinesh sir. I will forward now. Whatever
Okay.
vector
Okay.
calculus part I have discussed, no, I will upload in the drive. Questions part is there. That's fine,
Okay.
right?
Okay, sir.
Questions part,
Okay.
solution part not required. Anyhow, I was
Yes,
discussing
sir.
in the
Yes, sir.
class. Yeah.
Yes,
Then,
sir.
right. Okay, then we will see in the next class. Okay.
Thank you,
Good night.
sir.
Thank you, sir.
Yeah, thank you.